Okay, based on that table, we'll solve some problems here. Example, in triangle ABC, right angled at B, AB is equal to 5 centimeters and angle ACB is equal to 30 degrees. Determine the lengths of the sides BC and AC. What is the triangle is given in the problem? ABC. Which type of triangle it is? Right angle triangle. At which angle it is right angle? At angle B. Then what are the given two angles? Then the remaining two angles are to be acute. In that acute angles, one of the angle is to be given. Two acute angles are to be angle A and angle C. Thus they give that only angle C value, that is 30 degrees. And one more side is to be also mentioned in the problem, that is AB is equal to 5 centimeter. Then you can find the remaining two sides of that right angle triangle. Okay, based on that we will draw one diagram like this. ABC triangle, angle B is 90 degrees, okay, angle C is 30 degrees acute, and AB is 5 centimeter. Okay, these are the values are to be known based on the problem. Okay, we will find that BC length and AC length. Okay, coming to that concept, given in triangle ABC, angle B is 90 degrees, AB is equal to 5 centimeters, angle ACB is equal to 30 degrees. Then tan C is equal to, already we know that what is the formula for the tan C? Opposite by adjacent. For which angle opposite? C opposite and C adjacent. Clear? Opposite by adjacent. For C angle, opposite side is AB, adjacent side is BC. So C. AB by BC. Well, I mentioned the measures what we know in the problem. C value is 30 degrees, tan 30 degrees, that is equal to AB value is 5 centimeters by BC, 5 by BC. Okay, so tan 30 degrees, already we know that. Okay, must and should you know all these values to solve these problems. Okay, so tan 30 degrees, what is the 30 degrees for tan? It's a tan, but it is 1 by root 3. 1 by root 3 is equal to 5 by BC, 5 by BC. So then by transposing the values, BC is equal to 5 root 3 centimeters, 5 root 3 centimeters. Then coming to that sin C. Sin C. Why you can use the tan C and sin C only in the problem means, so if you find this value, it is adjacent side, it is opposite side, only, sorry, it is a hypotenuse, it is adjacent. We will find the adjacent and the hypotenuse in the given triangle. Just we know the opposite side. Okay, so to find the adjacent value by using the opposite side, clear? To find the adjacent value by using the opposite side, must and should we use that either tan trigonometric ratio or cot trigonometric ratio, either tan or cot, to find the adjacent by using the opposite. So we'll use here tan. Okay, so it is completed. Now coming to this, what is the remaining length? AC. Okay, it is a hypotenuse in the problem. By using the opposite, we can find the hypotenuse. By using the opposite, we can find the hypotenuse. Okay, so opposite and hypotenuse. What is the trigonometric ratio we can use? Sine or cosecant. Sine or cosecant. Okay, so one doubt will arise in the situation. Sir, already we know that the adjacent side based on the tan. So then automatically can we use that adjacent to find the hypotenuse? No problem at all. Okay, so by using the adjacent, we can find the hypotenuse, but we can use the trigonometric ratios to be cos in the situation, either cos and secant. Clear? Either cos and secant. Okay, so by using the opposite to find the hypotenuse, we can use the sine or cosecant. By using the adjacent, we can find the hypotenuse. We can use that either cos or secant. Okay, and one more procedure is also to be there. So already we know that opposite. Based on that, we can find that adjacent. Then to find the third side in that, so shall we apply that Pythagoras theorem? Okay, sure, we can apply the Pythagoras theorem. Hypotenuse square is equal to side square plus side square. Okay, side square plus side square. No problem at all. What is the procedure you can solve to get the answer? Okay. Then coming to that, here you can use the sin C opposite by hypotenuse. Opposite is AB by AC. Then sin 30 degrees is equal to 5 by AC. Sin 30 value is 1 by 2. So how can you know, sir, sin 30 degrees value is 1 by 2? You must by heart, otherwise you must understand, otherwise you must know these values. Okay, sin 30 degrees is equal to 1 by 2, that is equal to 5 by AC. Then AC is equal to 5 2. Okay, by cross multiplication, AC 1 into AC 2 into 5, 2 5 sir, AC is equal to 10 centimeters. These are the required lengths. AC is equal to 10 centimeters and BC is equal to 5 root 3 centimeters. Clear? Then coming to the second question, in triangle PQR, right angle at Q, PQ is equal to 3 centimeters and PR is equal to 6 centimeters. Determine QPR and PRQ. Determine QPR and PRQ. In that previous problem, you find that lengths of the sides, but here we'll find the angles. How many sides are to be given? Two sides are to be mentioned in the problem. Okay, one of the angle is to be right angle. Which is the right angle here? Angle Q. In PQR triangle, angle Q is the 90 degrees and PQ is equal to 3 centimeters, PR is equal to 6 centimeters. So based on these, we'll find that angle R measure, angle P measure. Okay, so we'll see how we can find those values. Given in triangle PQR, angle Q is equal to 90 degrees, PQ is 3 centimeters, PR is 6 centimeters. So these are to be opposite to that R. So to find the R value, okay, to find the measure of angle R, this is the opposite hypotenuse. Opposite hypotenuse is sine or cosecant. Okay, means sine R is equal to opposite by hypotenuse. What is the opposite here? PQ. Hypotenuse is PR. Clear? PQ is 3 by 6. 3 ones are 3 twos are. Means sine R is equal to 1 by 2. Sine R is equal to 1 by 2. 1 by 2 is the value for which angle in that sine trigonometric ratio? It is a 30. So we'll write as that 1 by 2 is also to be equal to the sine 30. Sir, it is also to be equal to cos 60. So why you can represent as a sine 30 only? The doubt will arise in the situation. Okay. So but we can use the sine 30 degrees only. Why? Because here it is comparing with the sine trigonometric ratio. This side is also to be represent, the value is also to be in the sine trigonometric ratio. Okay. Sine R is equal to 1 by 2. That result is also to be equal to sine 30 degrees. So generally we can use the word remove the sign on both sides. Okay. So but we can't remove that. So based on that, by cancelling or by removing the sign on both sides, the values are to be R is equal to 30 degrees. So means R is that 30 degrees means this is the angle for vertex R. Means it is that angle PRQ is equal to 30 degrees. Angle PRQ is equal to 30 degrees. Then it is completed. Now one more angle, that is to be QPR. Now it is QPR. So for P angle, it is a hypotenuse. For P angle, it is adjacent. What it is? For P, angle P, it is adjacent, it is hypotenuse. To find that angle P, adjacent and hypotenuse are to be known, then automatically we can use the cos trigonometric ratio. Means what to write? We know that cos P is equal to adjacent by hypotenuse. Adjacent by hypotenuse. Adjacent is PQ. For this. For this, it is adjacent. PQ by hypotenuse. It is constant. Hypotenuse only. PR. PQ by PR means 3 by 6. That is equal to 1 by 2. Cos P is equal to 1 by 2. Now this 1 by 2 is to be comparing with the cos trigonometric ratio only. Why? Because we are taking that it is cos P. It is equal to 1 by 2. That result is also to be equal to cos 60 degrees. Compare with the cos only. Okay. Then, so by removing the cos on both sides, P is equal to 60 degrees. P is that angle QPR. In the triangle, angle P means angle QPR. Therefore, angle QPR is equal to 60 degrees. QPR is equal to 60 degrees. Okay. So this is the way to find the required measures in the given question. Okay. By applying the trigonometric ratios for some specific angles. Okay.